Yes, well, welcome once again. The fourth session on signal flow graph, that is module 2 of control engineering. So here once again signal flow graph. So as you see, in case of block diagram, the disadvantage is, so each time you have to redraw the block diagram. That is the deepest task. That will lead to unnecessary time consuming and also the space consuming. So that by that we can have some errors. So in order to avoid that one, we are having the signal flow graph to get the overall transfer function by using a Mason gain formula. So here in case of signal flow graph, it is the modified form of block diagram which having the pictorial representation in which how the components are connected with one another using nodes and branches, and from one node to another node how the signals are flowing, that you can see here. So the signal flow graph and the block diagram representation of a system yield the same transfer function. So by using both the methods you can have the same transfer function, there is no doubt, but only thing the methods are approaches are different. So here in case of signal flow graph, when the system is represented with signal flow graph, the transfer function is obtained easily and quickly without using the signal flow graph reduction techniques. So here in case of signal flow graphs, sometime what happens, you will directly give the signal flow graph diagram and asking to get the transfer function. So sometime you will give the block diagram. So by using the block diagram, once again you have to convert into signal flow graph diagram. So there your task is to draw the signal flow graph from the block diagram by considering nodes and branches and arrows from which point to another point, what transmittance or transfer function is, that you have to consider. That is nothing but the transmittance. So here we are having branches and nodes. So transmittance here, when the signal flows from one node to another, the signal acquires a multiplication factor or gain. This gain between two nodes is known as transmittance, and it is indicated above the arrow mark in the branch. So here once again it consists of branches, nothing but the systems, and nodes, nothing but the signals. So this branch here, from one point to another point, if you take, this is one node here, another node here, and this is the transmittance, that is G of S, that is shown here in the amount of nodes, that is input node or output node, maybe like that. Okay. So here in case of signal flow graph, your aim is to find once again overall transfer function or control ratio or simply the transfer function using the Mason gain formula. So both the approaches are different to get the same result, that is transfer function. In the exam it is asked, solve the block diagram to get the transfer function by block diagram reduction method. So here in case of signal flow graphs, sometime you give the directly signal flow graph diagram or sometime you give the block diagram. So there by using the Mason gain formula, find the transfer function, he may ask. So here once again just see here using the in case of block diagram, you see this is the input, this is the output, this is the block having the transmittance. So in this case each step by step block diagram is to draw, that's why it is tedious method and time consuming, and that is the wastage of time and space. But here in case of signal flow graph, it is input R of S taken as input node and C of S taken as output node, and this transmitters nothing but the gain with the arrow mark. So only one time signal flow graph is to be drawn, then the Mason gain formula using that one you can evaluate. So here the time and space is saved here and it is errorless. So here we can understand what is that the signal flow graph diagram using this simple signal flow graph diagram. So here we are having x1, x2, x3 and x4. This should be x4, sorry, this is x3 dash and x4 is here. So these are the some nodes 1, 2, 3, 4 and this is 5. So this is called input node or source node. So one more input node is here, that is x4, and output nodes are, this is output node only x3, only incoming branches to the output nodes, but from input node only outgoing branches. You see here x1 only outgoing, and even this x4 is also only outgoing branches, and these two x2 and x3 are mixed branches or mixed modes. So there incoming branches as well as outgoing branches. So from here it is incoming, from here it is incoming and outgoing. And in this arrow mark it is shown here the transmittance A, B and here C feedback loop, and here D from x4 to x3, and here it is 1. If nothing is there, you can call as unit transmittance. Okay. So here once again this is called branch, and these are transmittance A, B, C and D, and 1 are transmittance, and these are source node, and this is sink node, and these are mixed nodes. Okay, so this keeping in mind, you can have the, what is that, the signal flow graph diagrams. So here some of the basic term definitions. What is that? The forward path, it is the path from the input node to the output node with no node being traced twice. So only once you have to travel from input to output. No repetition of the node should not be takes place. That is called the forward path. Only one path, only one time it is traveled from input to output node, that is from source node to the sink node. So path gain, the gain of that particular forward path. If there are one forward path, the gain go on multiplying the transmittance. If there are two forward path, go on multiplying the transmittance. So if there are 2, 3, 4, accordingly you have to take the path gain of all those paths. So it is the product of all the gains while traveling in the forward path, that is from source node to the sink node. In the feedback loop, it originates and terminates at the same node. So feedback loop is loop starting from the one node and traveling another node and once again come back to the same node. That is called feedback loop. It originate and terminate at the same node, traveling through at least one other node, along which no node is travels more than once. There should not be any repetition of the node in case of loop. And feedback loop gain, once again the transmittance of all the loops travel from one point to another point, finally to the original node. That is, it is the product of all the gains while traveling through the feedback loop. In the input node or source node, it is a node which has no incoming branches and has only outgoing branches. So input node only outgoing branches, no incoming branches. So what is the output node or sink node? It is having only incoming branches, no outgoing branches. A node with no outgoing branches has only incoming branches, or you can call signals. What is the mixed node? So here it is having both incoming branches or outgoing branches. The signal coming into this node and the signal going out of this node, that is called mixed node. What is self loop? It is a branch that starts and terminates on the same node, forming a loop. So it is a branch that starts and terminates at the same node, forming a loop. What is non-touching loop? The loops are said to be independent, means there is no node common between them, those loops. So it is a independent. No node should be common in between them. So this is what about the signal flow graph. We have seen the disadvantage of block diagram and what is the advantage of signal flow diagram. Why we are going for the signal flow graph diagram rather than the block diagram. So here you have seen the how the signal flow diagram looks like with simple sketch, and some of the definition we have seen: forward path, forward path gain, feedback loop gain, input node, output node, that is source node, sync node, mixed node, self loop. What is self loop? It is a branch starts at the same node and terminate at the same node, having some transmittance written on the branch. So at only one node. In non-touching loops also we have studied. And coming to the what is that? The Mason gain formula. How the Mason gain formula is used to find the overall transfer function. This formula is used to determine the closed loop transfer function or control ratio, which is also called as control ratio. Sometimes it is also called as overall transfer function, that is closed loop transfer function or control ratio or overall transfer function. So here output by input C of S divided by R of S, sometimes written as C by R, that is 1 by delta summation of Pk delta k, where k equal to 1 to n. So you summate all the S number of forward path and path gain and delta of that particular path and 1 by delta. So here if there are S1 forward path P1 delta 1 by delta, you stop there only. If there are 2 forward path P1 delta 1 plus P2 delta 2 divided by 2, stop there. If there are 3 forward path P1 delta 1 plus P2 delta 2 plus P3 delta 3 whole divided by delta. So like that. If there are n number P1 delta 1, P2 delta 2 plus P3 delta 3 and so on up to Pn delta n divided by delta. So here what is that? C is output node, R is input node, and n is number of forward path, and Pk is forward path or path gain at that respective forward path, and delta is how to get the delta value, that is 1 minus. So always should be less than that delta, that is 1 minus sum of individual loop gain, next plus sum of product of 2 non-touching loops, then minus sum of product of 3 non-touching loops, and plus sum of product of 4 non-touching loops, and so on. You have to take all the loops. What is delta k? It is that value of delta given by the equation here, neglecting those loops that are touching the forward path. So any loop should not touch the particular forward path, that is k. Maybe if it is only one forward path, for that it should not touch anything. So that loop you have to take here, that is 1 minus of that value. That is called, what is that? The delta k. So here we have seen what we have seen, the signal flow graph, that is how to draw the signal flow graph diagram using the block diagram, or sometimes directly given the signal flow graphs, and how the signal flow graph diagram looks like here with simple signal flow diagram. So in that one we have seen what is that? Node, branch, source node, sync node, mixed node, what is transmittance, and what is loop, what is forward path, all those things we have seen here. So one more thing what you have studied here, the disadvantages of block diagram. What is that disadvantage? So in case of block diagram, in order to find the overall transfer function or control ratio, so we have to reduce the block diagram step by step by applying those block diagram rules. Maybe combining the blocks in series, combining the blocks in parallel, shifting of summing point, shifting of takeoff point, shifting of summing point ahead of the block, shifting of summing point behind the block, shifting of summing point, takeoff point ahead of the block, shifting of summing point behind the block. So like that, and summing all the values. So like that, some basic rules are there to draw the to decrease the block diagram into simple form or canonical form. But here in case of signal flow graph, there is no such reduction of signal flow graph. Directly if you draw the signal flow graph, sometime from the block diagram to directly signal flow graph, sometime it is directly given. So by using the Mason gain formula, you have to find out the overall transfer function or control ratio. So So once again here, coming to the Mason gain formula, that is very important. How to get the overall transfer function using the Mason gain formula. Okay. So this is a simple equation through which you can find the overall transfer function, that is C by R. So with this I can conclude this session.